Hi all, I am Vijay Jethani. So as a part of AZ-204 exam blueprint, we have 5 modules to cover. Module 1, Developing Azure Compute Solutions. This we have covered already as a part of session 1, where we have covered the Azure PaaS services, mainly Azure App Services, Azure Functions, and even the containerized solutions, which is nothing but the container instances, container apps, and the container registry as whole. So as a part of session 1, we have completed the developing Azure Compute Solutions. In session 2, that is today's session, we are going to cover for Azure Storage, which mainly covers developing solutions for Azure Cosmos DB and Azure Storage. Now, in upcoming sessions, that means session 3, 4, and 5, we will cover implementing Azure security, similarly monitoring, troubleshooting, and optimizing Azure solutions, and connecting and consuming Azure services along with the third-party services. So this is a brief exam blueprint of what we are supposed to cover as part of this exam preparation session. Okay, so now let's move with a brief of what we covered as a part of session 1. So these are blueprints, you can say. We have covered from compute services on Azure, which are nothing but the PaaS services, and then we drill down mainly into app services as a platform. Then we covered the different plans around that, how the deployments works across the app services, and then we came to another compute, which is an Azure Functions, which is nothing but a serverless compute, how they interact with the different services, what are the plans for that Azure Functions, and then we ended up with the Azure Container Services. So this was a brief about the first session, which was on developing Azure Compute Solutions. Now today's session, let's come to that for developing Azure Storage. We will cover mainly on Azure Cosmos DB and Azure Blob Storage. Okay, so let's start with the Cosmos DB. First of all, for Cosmos DB, let's look at how that is structured. That means how we are actually going to create an Cosmos DB within our Azure subscription. So it starts with a database account, and then we have a databases within that, followed by a container. Now container, depending upon the APIs we are using, that can be a collection of documents, that can be a table, graph, or key value pairs. So these are nothing but a semi-structured data basis, or you would say a collection of data in some shape and form within your container, which is a semi-structured. Okay, so that is what we have at this point of time at high level overview of Cosmos DB. Okay, similarly within the collection, that means within the collection of documents and the tables and the graph, each item will correspond to either a document or row or column, node or edge, depending upon what APIs we're using. Now let's look at the Cosmos DB APIs to understand this further. Now these are the Cosmos DB APIs. By default, a native API is NoSQL, which is kind of, if you want to really build out the greenfield environment, then this is the best option within the Cosmos DB to go for API for NoSQL. What are the advantages over the other APIs? First of all, as this is a native to an Cosmos DB, any updates or feature sets will be first coming to a NoSQL API, then to another APIs, which are nothing but MongoDB, Postgre, Cassandra, Apache, YAML, and Table. Okay, so this is how the updates are released from a Cosmos DB as a product. So on another APIs like for MongoDB, PostgreSQL, Apache Cassandra, Apache YAML, and API for Table, basically here you are leveraging existing open source system. That means I don't want to change anything from a database access layers. Also, my application will be interacting same the way they were doing it before. Now, only advantage I will get here is I'm actually bringing the capabilities and feature sets of Cosmos DB of multi master model, geographical distributed, and also the consistency level, which we are just going to talk about in a moment. So that is what the Cosmos DB APIs look at this point of time. So from Greenfield, I think it's more of an API for NoSQL. Similarly, if you have to leverage existing, then these are the 5 APIs which you can leverage using existing open source systems. Okay, so I will just pause here for a while before we move further. Now from exam point of view, I think there can be short question on what is the greenfield versus what you can leverage existing. So you should be sure of which APIs are available within Azure Cosmos DB. Okay. Now moving ahead, again, this is an different representation of SQL API, Cassandra, Mongo, Joomla, and table. And what this is, I'm just bringing out a one-liner for that. So as you have seen the collection which was under the database, if you see for API for NoSQL, this is nothing but a document format. Similarly, API for Mongo, this is nothing but a binary JSON format. Apache Cassandra, mainly a column oriented schema. Table, again, this is a key value format. Similarly, for Joomla, I think it is more on the nodes and the edges, how you look in form of a graph or a special database. Postgre, again, this is leveraging a capability more on how you do a multi-master model. Okay, so these are the APIs which you need to remember as a part of this exam, and what are the different formats they support. So as you have seen the collection item within the database, based on which API you are consuming, the format in which the data or semi-structured data changes. Okay, so you have to remember that. Now coming to this particular diagram, I think this is a good representation of how a Cosmos DB looks like. First of all, a multi-master and a geographically dispersed or distributed database, and then you can bring down everything right from a scale, low latency, and obviously you can achieve your SLAs. But main important to look at is the different type of semi-structured key value pairs, column family, document graph. So different types of data stores it can hold within that particular database, right? And you can also expose them. If you are going with a greenfield, we already talked about NoSQL, but if not, then whatever you are leveraging before, you can actually leverage that without even changing your data access layers. Okay, so from exam point of view, it is important to know what Cosmos DB is and what APIs it is built on. Another different is what are the consistency level. Now, as we are having a different kind of databases, or I would say an APIs, it is also important to know what is the best fit for these particular APIs. So that is where this consistency level comes into picture. Now, what exactly that is? So if you see from left, which is strong, going ahead till extreme right, which is eventual. So when I say strong, that means at any point of time, if any write happens on a particular database, then while I read that on a replica, it will give me exactly the same what was written before. Okay, that means I want to read exactly the same data if it has been written. So that is where the strong consistency come into picture. But ideally, this is possible within your own region, or I would say a data center, which are very near to each other and have good connectivity, a low latency environment kind of thing. But if you consider a multi-master model which is geographically distributed, it is very difficult to achieve a strong consistency within that. Okay, so with that, the best option would be to go for bounded staleness. That means yes, the commit will be there, but the the strong will be followed for a near data center or the near, I would say, an availability zone within that particular region. But for a geographically remote region, then I would be obviously a stale data for a, I would say you can consider a 5-second interval kind of thing, which will be a stale that is running behind 5 seconds from whatever was committed at the primary. And this is also an important point. That means if something goes wrong at the primary, you still have few seconds to stop it if you really know that, or even delay it for that particular time interval, or that is being reflected at your secondary region. Okay, so that is how you look at from the bounded staleness. Similarly, the session. Now session is mainly for the users. That means if a user is accessing that particular or using that particular any website which is using CosmosDB as a database, then for that particular user, the transactions will be committing exactly in the same time frame for any, say suppose now I'm accessing from one data center versus accessing from another data center, which is nothing part of an availability zones. So for that, obviously I need a same kind of consistency. If I'm on a shopping website, I'm doing some e-commerce related stuff on that particular website, I want the latest data to reflect there. So that is where my write and reads should be in sync before I can actually do the transaction on that particular website. So session is important from a user aspects. But what if I really, at this point of time, there are a number of transactions happening for a vendors also on that particular e-commerce website. I really don't need the strong or bounded staleness kind of consistency level. In that consistent prefix, that means at the end of the day, I would kind of look into that what exactly is being done for that, or what are the new products having come from that vendor, or what are the changes being happening for that vendor from pricing aspects and all different things which I can fit into that website. So consistency prefix is kind of, it will provide the updates of, or I would say a write to a secondary region, but it will be running behind some by a consistent time or a consistent prefix, which is nothing but some, you can say if n is the current, then n minus 1 or n minus 2 is what you will say the interval for that particular to reflect at that particular remote site. Okay, so that is where I'm assuming from a consistent prefix. Eventually is as we have been already talking about, like a vendor products being updated at the back end. So eventually is actually irrespective of whatever happens, I only need to check my data should be in sync after a day or so. Then in that case, or maybe I would say even few hours down the line. So eventual is, it works better for those particular consistency level. Now let's look at from a graph perspective, because we all understand a pictorial representation a better way than actually looking at from a wordings. Now this is how the strong consistency looks like. As I said, I want whatever data being written within the region or availability zone, they should follow this kind of a strong consistency. That means whatever is being written in West US, and if I want to read that, exactly same data I read. That means what I'm trying to say here is, first these writes are committed to a secondary regions and then to a primary. This is what is exactly the same we do in the synchronous communication, right? When we do a database synchronous communication, first it is written to a secondary region or a secondary replica, then it is written to the primary replica. So this is exactly what the strong consistency means. At any point of time, either the data is written fully or it is not written. That means primary and secondary are completely in sync. Here this is meant mainly from a different regions. So if you see West US2, if I consider this as a primary, similarly if I consider secondary region as East US2, they should be exactly in sync with whatever has been written to a secondary regions. Now let's understand the second consistency level, which is bounded staleness. Now, as I already said, it is stale. That means it is lagging behind. So what I meant by this is if I write to that particular region, then it should be a kind of a strong. Correct? If I'm writing a different region, then it should be lag behind some interval. It can be some versions or a 5-second interval or something of that sort. That means what I'm trying to say here is, even though whatever I'm writing, we have follow the strong consistency within the same region, but for other regions it is lagging behind. That means I'm not reading consistently at this, so it can lag, but what you see here is the data is exactly in sync or in an order which is written to a secondary region as well, which is a bounded staleness. That means exactly the same, a lag of some particular versions or a time interval. This is a bounded staleness. Now look at this session. Now when we look at the session, it is more from a user. Okay, as I have given you example of e-commerce website, if a user is working on one particular or being on logged on to the one particular website and something goes wrong on that particular region, or I would say an availability zone, so within that particular this follows exactly what you see, right? From within the same region, this is either written or not written. But if I consider a second region, which is East US2, as this is for one particular that user, it should return being the data is written immediately for that particular small or whatever the transaction that particular user is doing. That means session A here, which user were logged on, should be follow exactly same. That means if I have written something, I should be able to read that, is what I meant from the session consistency for user. Now this is not for overall, this is just for a user session. Again, you can call this as a strong consistency for that user. But what happens if that session is lost or I re-log into that e-commerce website after some time? In that case, obviously, if I'm initiating another session, okay, from a different particular region, in that case I will see a lag. So what I meant by is, if the session is alive for that particular time duration or whatever is being set at the application level, I should be able to use the e-commerce website without any challenges. Now let's look at the fourth option, which is the consistent prefix. Now here I think we have already saying that this data will get replicated with a consistent lag or consistent prefix. Okay, so consistent prefix is, if you see the first bit being written exactly within the same, but the another bit is being actually lagged. However, there is no out of order. That means still the data is written in an order. That means if I want to read the second bit, obviously I would be able to only read after some point of time. This is what the consistent prefix. That means at this point of time, the good example which I've given you were the vendor products changing at the back end, or new products are being added at the website at the back. So for those kind of the data, the lag is okay for me. And this is not a transaction related data for that particular vendor. I can wait for that particular time interval for the data to be available. So at this point of time, I can only read this first. This, say, consider this as a product. I can only read this first bit as a product. However, if you see at the end of the day, they will coming back to being written fully, whatever all the bits are there here. Okay, so what I'm trying to say here is, not everywhere you will require a strong consistency, and where the strong consistency is not required, you can go with the bounded staleness, and the worst case or one-to-one, I would say for user following the strong consistency is nothing but a session consistency. So these are the three above which I have been talking about from a consistency. Fourth is more of a lag, which is I don't need to read them immediately. It can come at its own time because this is more of a product being added than actual transactions being done on the website. Okay, so this is sufficient for me at this point of time from a consistency aspects. Now another consistency level is the eventual consistency. In this again, if you see these bits, now if you see even for the same region, I am not able to read them in a same fashion. That means they are out of order. So eventual means at some point of time they will be out of order, but at the end of the day or after some time interval you should be able to have the data available on the secondary, even the primary region for reading. So this is required when you don't need to wait for any particular commit on any particular region. That means obviously the primary region is committed immediately, and then secondary region will take some time, or there will be lag after that particular data related or semi-structured data is replicated to that particular region. So this can even happen within the same region versus the other region where it is replicated. So this is mainly for where we don't need an immediate read after write. Okay, so remember again, coming back to the 5 consistency level, to summarize, this is what it looks like from a table. Strong, write is only performed once it is replicated to the replica in simple sense. Stale, it is having a lag behind some k versions or some time interval. Session is more of a strong, but now it is a particularly for that particular user. Consistent prefix, I don't need a immediate read after write, or even after some point of time this is okay. So this particular consistency level is good for me. Like I can give you also one more example, like from an while we do the billing at our hospitals, not all bills are uploaded at the same time. They, if I have to create a final bill, obviously it will be consolidated from a different pharmacy and all those things, from pathology labs and everything. So in those particular environments I can have a consistent prefix. That means at the end of the day I would be knowing what will be in my final bill. So that also will be a good example for constant prefix. And obviously the eventual is more on the, as we said here, the write operation. If there is a read operation followed by write, go with the strong consistency and then come down slowly depending upon your requirements. But if there is no such need, that means you are able to wait for the data to be available at the secondary side, or you don't need immediate read after write, then you can follow which specific consistency level best fits for you. Okay, so this is an I would again pause here for a while so that you can look through this particular table before we move further. Okay, so let's move further. Now why we have understood this consistency level, what is the best real world examples so that we are sure what kind of the consistency levels we have to use. Now if you consider for NoSQL and the table, I think it is, you see the session consistency is optimal and the recommended options, because here mainly you will be dealing with the user sessions and the session specific related data. So the session consistency is optimal and the default option, I would say. Also, if not going with a strong as immediate read after write, then most of the cases where you are using multi-master model, the bounded staleness will be a preferred consistency level. Correct? Also, it is being recommended if you need the highest availability and the low latency. That means you really don't bother about reads. You just want your data to be written at this point of time. Eventual consistency, that means the last level which you have seen is the best for that. Now looking at the Cassandra, Mongo, Apache, where we are using our own open source systems, there we are using a wire protocols. The best for that consistency is your default, nothing but the your session based consistency. Okay, so most of the time it will be a user related sessions profiles. So you will follow a default consistency of session in most of the cases, unless and until you require really a strong consistency in case of our payment transactions or something of that sort. There obviously you need a strong or minimum of the bounded staleness consistency level. Okay, now let's see again, this is an again the wording what we have said already. A consistency guarantees for read operations corresponding to freshness. That means if I want to immediate read after write, then follow from the strong and come down below to whatever I need that. But from the best practices aspects, bounded staleness is required where you should be used where you require a strong consistency considering multi-master model. And for eventual, we would suggest again to use a consistent prefix versus eventual, where you wanted the data to coming in order then coming out of order in eventual consistency. So the best practices purely varies based on whether you want to read the data immediately versus you just want to write the data. That's it. Now this was the consistency and the structure and what kind of the data it stores in a semi-structured form. Now what about from an exam aspects? I think they test you pretty much everything on how you should design the model around your, or how would you structure your database creation based on different APIs you're using. Similarly, how the multi-master model will work, and how are you actually storing or partitioning the data so that you are able to read them parallelly versus synchronous read. Similarly, how do optimize the search from those particular database queries and all those things. So that is what we will cover in our next, which is operations with Cosmos DB. So let's get started with the first, which is a data modeling. Now this is again the publicly available link. You need not bother about for getting this. Just remember what are the topics we are covering and you should be able to get that publicly available link. Now with the data modeling, important aspect is, even though we are saying this, it's a schema less and all those things, but still we have to have something in our mind so that we can get a best performance and scalability from these particular databases, right? So if you see, if I come to the example, now here the example is, this is the example how this a person or a different, I would say, is a different person details along with whatever the transaction that person does is represented in form of a the transactional database. This is how the transaction look and feel is. But if I want to embed exactly the same kind of the person and what kind of the details, like let it be from address and all those things that he has or she has, now we have to have this in a form of a semi-structure, that means a document. So how that will look like and how you will actually save time, or I would say read them without even doing the heavy joins. That means, say if one particular, if you see the transaction database, you have one person and he does some transaction. So a person versus transaction versus whatever shopping products is buying, all are stored in a different tables, and then you join them to bring a unified view out of that. That means this person if has done the shopping. So in short, what we are trying to do is person then shopping catalog, and whatever the transaction he has done. We are combining all of them and doing some kind of the operational work on top of that. But this is an costlier affair in terms of the when the data is being given back to us, or how fast we can retrieve that these particular data. While in case of a semi-structure, we can create one particular simple document. So that is what is being represented in this particular use case. That means if I really want to embed this kind of data, all I have to do is create some kind of a JSON. And for creating a JSON, obviously I would need the some structure. Now this is purely your transactional structure of how you are getting the data of the person doing some transactions along with the address and all those things. This is a semi-structured form of how this will be represented in a Cosmos DB. That means you know the key value pairs, that person will require some kind of identification along with the name, addresses. And the advantage here is, if you see this is very much, that means if I want to add another address, I want to really create another structure or schema for that. If I want to have additional details, I should already have that schema or that column available for me before I add new details. But here, in case of a semi-structured, I just need to add that a new key value pair. So that easy, that means what I'm trying to say here is, reading a JSON is will be faster compared to what you have in a transaction join operations which are performed on the transaction database. So this is what the modeling they are talking about. But we need to be very careful in terms of what exactly we will need or what key value pairs, and just you need to amend that in a proper format. If say suppose in a document structure, it will be obviously the key value pair similarly is for your table storage. But if it is in terms of your graph, or when you are connecting the different edges and the nodes, you should know what are the different nodes and everything. And obviously if it that increases, or maybe that there is an expansion further, we can add more edges and nodes to that. So the advantage over the transaction data is obviously that is an incremental and has a good flexibility, that it need not be a fixed schema. That is where we are talking about a schemaless. So this example I think is very, if you go through this example, it gives you a different how the look and feel of the semi-structured data in the Cosmos DB will look like versus the transaction database. Okay, so in interest of time, I think we will move to the next topic, but this is an important from how the modeling will look like, or how do we model the, or how will you actually map a transaction data versus schemaless free data in a Cosmos DB. Okay, so let me close this out and start with how this looks in a. Now, as this is an Cosmos and supports different types, how would the actual regions, or how this is taken care at each region level, how the data is actually replicated. Now again, remember the basic remains same. You create an account, you create a database and have a collections. Collections can be a document, can be a key value pair, can be a graph related data, a semi-structured data. But from the considering how actually this is a multi-master model is where this topic will be focused on. Now if you see the multi-master model, what we have is we have a different regions than data centers and the different kind of the stamps. That means you can consider them as a pods, and followed by the fault domains. Now each of these, if I want to actually map them to a respective what kind of the work I'm doing, a multi-region, this will look like something similar to this. That means at first place, what I have is the structure being created, and obviously I need add this is also a database. It will require some kind of compute and storage. So I would obviously have a physical location or the some regions where these particular clusters are created and the storage being provisioned. Now on top of that is a logical structure. The logical structure is nothing but where actually our collections, or we should be able to query our APIs and bring the right data using those logical connections, or I would say a partition keys, which knows which data is stored where. Okay, so that is where you see the tables, collections, and the graphs are stored in the containers, which is nothing but a logical uh, entity, which is referring to a specific clusters, and within that clusters obviously there is a storage where actually the data is being stored. Now this gives you how this particular uh, the data is stored across the multiple regions, region 1, region 2, and how the physical partitions vary different from the partition set, or I would say a logical representation of that. So this is also a good representation of how this is actually taken care. Now again here this is a show of how exactly the primary is forwarding the data, or the followers are actually consuming the data from the primary and then getting that replicated to another regions. So this is just an example of that. And how do we resolve the conflict? Obviously there are different algorithms. There are last write wins versus an application defined conflict resolution, which you can at this point of time leverage for using, which is actually the bad versus the right data. Or if you have written some logic, that means this is like say if I am validating some of the fields, that means what I am expecting to be written, that means it should have all the fields filled in, or some kind of the validation checks I'm doing before writing the data. That is what the simple application level logics look like. Last write wins is irrespective of whatever is being written, I'm just making sure that whoever has written last wins from the write per se. Okay, so that is what is shown here. And this structure, first of all, this structure is very important to remember how these particular uh, a replication works at the back end for the Cosmos DB. Now coming to the partitioning and scaling. Now this is again, till the time we have just seen the how the regions are there, how we are actually seeing the physical partitions, but actually looking into how this actually translates to a logical partitions and how we are actually consuming them is shown here. Okay, like say whatever the different types of items, and like say suppose again taking the example of our e-commerce website, the our food products versus our household appliances or something, you can actually group them in a logical partitions, and then according to that, while you try to fetch some data from that, I think it will be referring to a specific physical partitions, or a cluster, and then fetch you that particular data from that. So ideally what we are trying to say here is the physical structure is always created at first, giving you go ahead with yes, now you can actually work on that, but logical is where actually you get the value out of the how you're trying to store. That means there should be a logic behind storing the data in or grouping the data, so that it is easy. Not only it gives you a performance, but also it should be able to parallel read versus sequential reads. Okay, so this is what the logical partition of different products you can look into. Similarly, physical partitions, I think it's more on the what kind of the processing power it has, the cluster has. So based on that, I think you will have a logical partition sitting on the physical partitions uh, to actually consume those APIs and work on top of that. So this is what the basics I think you need to remember from an exam point of view, because the exam the specific questions will be, as I said, mainly on how the structuring is there, which kind of the greenfield versus the existing, what you can leverage. Similarly, different consistency level, what are the different type of the partitions, logical versus physical partitions. Similarly, what kind of the resourcing or the power you have within the clusters, what kind of the maximum limit you have for a physical partitions. So these are the few things you have to remember, and based on I think your understanding, it will be then easy to crack that particular exam. Okay, so this was for the partition and scaling. Now coming to indexing. Now what is the use of indexing? Now a simple example, if you see, is to the way you have a logical partition, we should also have some kind of a indexing set so that we can easily search the data within those respective semi-structured data containers, right? So like you should include something and exclude something that which we don't want, so that it will be easy to scan through the complete bigger document within no time. Okay, so that is where the indexing policies will come into picture, and there will be short question on this, and you will also be given the code. You just have to map based on whatever the example they have, you have to map. But important thing to note here is just see the structure, whatever the path you have including, whatever path you are excluding, make sure you remember these structured as a developer, because here the code will be more major code will be on JSONs, so that you should be able to map them. Also there will be the CLIs which you have to actually map to create those particular drop down. So this example will vary, but I think sure there will be question on indexing where you will include the path. The similarly these are the policies. Okay, so these policies works on top of whatever you have created as a data structure. Now if you see the example, uh, using a special index on a specific property path only. Now you are clearly going to the root, then you are excluding a specific path which has e tag. That means this is the tagging, they does not have more of a data. But after these indexes, I am making sure that what kind of the geolocation I want to track. That means respective points, polygon, multi polygon line string, I want to really be able to fetch based on the request I provide through these APIs. Now if you see the composite example also, you will actually try to do some kind of filtering, or I would say run query on top of that and filter the data in shape and form which you are able to understand. So the ascending, descending and all those things will to come into picture. So this is a kind of a logic you are applying on top of whatever you have seen through. Okay, so how you see this logic in that particular JSON is what is represented here. So I would say just go through these whatever they have given from an example aspects, and this is exactly what they ask you in exam as well. Some kind of a construct you will see, and then some kind of the query you will apply on top of that, and there will be also responses towards that. Okay, so while you try to do these particular indexes and the responses, you will actually see that you are able to get out of the exactly the mechanism to creating these indexing policies on top of your data. Okay, so this example whatever they're given is very good in terms of understanding what to include, what to exclude in your indexing policies. Okay, so I'm just pausing here for a while just to for you to just bookmark whatever I've been showing just now. Now let's look at what is a change feed. Now change feed is nothing but if I want to really track out what are the changes being happening to my database. Now there should be someone who should be tracking each and every transaction. That means update is happening, insert is happening, or something is getting deleted, so that I should be able to really track or audit that for a compliance reason and for the different specific restore work I can do on top of that. Okay, so this is where the change feed processor come into picture. And again, will be an important topic from an exam point of view, where you will be actually be asked about different components of the feed processor. So as I said, we are monitoring each and everything what is being done on my database or data. So obviously I have to monitor something. So there is a monitored container. There is a lease container. The lease container is nothing but a temporary storage where I can actually pull out a respective state that what happened on that one particular time interval for that particular container. So I'm just keeping this transaction, some update happen. I just want to keep track of that in a, or want to store the state of that in a lease container. So this is what is happening. A compute instance is nothing but what exactly I have to listen for. Okay, so this basically, obviously, as I'm saying, it is a processor, it will require some kind of compute, and based on that, whether I can, it high power versus low power, I have to have either virtual machine or some kind of a container or something of that sort. So these are the components of the change feed processor. That means the audit mechanism, if I want to have on the data, I should obviously have these components. And then finally a consumer, that means a delegate. That means obviously whatever I am tracking, I'm doing for some purpose, and I want to feed this data to some consumer, which is nothing but a delegate. Delegate is a system which will actually consume based on if something changes, what are the corrective action I have to take on top of that. Like say example, if something is being written on the data store or maybe the container which is not right, then obviously I have to take the action on top of that. Similarly, if I'm just tracking how many update operations happen on this particular product, then obviously I can get the data, or I can refine the data and pull that in a form of report. But someone should consume that, is where the delegate will come into picture. And these all elements, you will be able to actually have your code, or I would say SDK, for each of right from your client and how you access the delegate and everything. You have a appropriate code for that. Already you have some kind of templates built in. Few of them you have to have a logic, which we already talked about before, with the help of indexing policies. Are we able to query that and all those things? So that is where this will be helpful for you to understand end-to-end operations of Cosmos DB. Okay, so change feed processor is more of a push model. Now let us look at the other things what we have, what you see from the. Now this is a before I think we move over there, I think one more thing. This is how the graphically this looks like. There are different regions and different the scattered. I think I would say partitions. The data is scattered, and based on whatever changes on respective data, I think the lease collection, which is in a container, that keeps tracks of what are the different changes which has happened, and these host 1 and host 2 are basically the consumers of whatever changes are happening on that particular. So change feed processor, whatever the 4 elements, I think you should know these 4 elements and what the purpose they solve for. Okay, so and as I said, there will be short code on this and how you interact with them in a programmatical way. This is an example. If you see how you actually create the different connection strings, different, I would say, parameters, and then create a different methods, how we call it and how we actually feed that to a delegate. Okay, so those are the different examples they have already given, and just go through them. And for each of the exam, this is more on a logical structure, I would say, and how the respective consumption of that particular happens once the change feed is available to a lease container. So this is from a delegate is more from consumption, and this is more from a how you see this in a code working for your own applications. Okay, so let's move on to the. Now this was a push model. This is more on a pull model. Now when you will use a pull model versus, so pull model is when you want the changes, that means you are not available 24/7. I want to pull the change at a respective time interval. That is where you will require a pull model. That means I want to consume. Okay, you do something, that means you're tracking the changes happening. But for me, I think I really want to look at to read a specific related thing, or I want to read this data at a particular time interval only. And similarly, to perform a one-time read of existing data is what I can do specifically on that particular semi-structured data. So pull model is used when you really want to receive the things at your own pace, or receive the data at your own pace. This is an comparison they have given change feed processor, which is nothing but the push versus a pull model. So I think if you see, I think there will be short again the question on what the state management and change feed processes done with the lease container, whereas for pull model continuation token is used for state storing. Okay, so this is what I think few of the things you can get from this particular comparison table. And again, working with again the pull model, the way we have seen the examples of the push model, you are being given the respective code for that. Just go through each of them. I think they are pretty much more of a logical construct of the different the methods you are building, the properties you are building. And if you are a developer, I think you are very well was aware of these particular depending upon the different stacks. Okay, so how you actually create the those particular tokens and everything is being written in this example. So in interest of time, I'm just moving ahead, but I think this change feed is also one of the important topic you will see in exam. Now these till from here, from modeling, indexing, change feed is the till here we were really looking out what are the operations we are doing and how we are tracking them. But how do we actually read the change feed is also an example you can look at. That is where I have just put this example as well, whether you are using push model versus pull model. If you see the how you actually do the whole the reading process, that means polling the change feed for future changes, storing state with a lease container, load balancing across multiple clients, because obviously you will have a capacity which you have already reserved for this particular activity, and then obviously handling errors or I would say an actions. Okay, so what you are using within that, I think they have given with a push model how this looks like versus pull model, how you are actually reading those particular changes and a different APIs which they have given. So again, just go through the code, whatever they're given these examples which I'm referring to. Now, while I write the queries, I think simple things which you have to make sure is understand what we have to first of all read for, and accordingly create your own query, or I would say a select statements in this case, where you are actually trying to get something from a JSON. Okay, so select everything from families where ID is Wakefield family. So with that, I think the result what you see, that means this is actually reading the full document, whole lot of document, and populating only thing whatever you require. So creating these particular collections and working on these queries will actually help you hands-on onto CosmosDB operations, what we do on the JSON or the different APIs. The most of the things I think you will see on the NoSQL or the document, but I think there will be also the APIs construct which will actually going through that particular the different writing of those particular queries on the different APIs. Okay, now coming to the security part. Now obviously security is what is required in every database or for any type of data we interact with, how this looks like. So important thing to look at here is first of all, nevertheless network security, firewall, user, these all things whatever you do at the platform level or protecting you from respective attacks and everything, what are the changes you have to do at the network level or the system level, which you will anyway do. But apart from that, what is more important thing is there is a obviously they have been providing the each and every, I would say, the best practices. Say so for network security, what are the respective IP addresses or a combination of IP addresses. Similarly, authorization, how that will happen, how the user permissions will look like. So they have given each and everything from a respective overall managing your Cosmos DB as whole is what they have given from. Similarly, there will be also the respective keys which you will be dealing with the respective APIs. So how do you get those keys? How do you rotate those keys? That is where they have mentioned in this particular document. So have a look over this. As I said, this will take time to go through. I would say at least you should have a couple of weeks to 3 weeks of time before you go for the exam on the specific topics. Okay, so you have to cover for each of them. How do you actually work with these particular different APIs? They have clearly given how do you rotate that, Important thing is obviously the role-based access control as well, how you actually create the respective roles and refine them in a such a way that only whatever the permissions are required are given and not more than that. Okay, so this was more on a security. Coming to the migration, now you will be obviously migrating from legacy or the different open source systems. So for that, I think what are the different steps you have to take is written in this particular article. So if you see, this is migrate data to Cosmos using the desktop data migration tool. This is a tool and it will help you from different sources, whatever you see here as of now. And the prerequisites also just go through how you actually set up the destination environment, and depending upon which machine you are using, just select that tool accordingly and perform or I would say create a user's respective CLI to create a respective accounts. Exactly the same, you have to create an account, then you have to create database, then you have to create collections, and based on the collections obviously the items will come into depending upon what structured semi-structured data you are trying to. And while you do the migration, everything here is a document base if you are doing for a greenfield environment, and obviously the JSONs and everything will be very handy here, which are the respective data or which are the respective APIs which are trying to use. So they have given completely a sync and a source versus sync model. That means you connecting to the source and then syncing into the some data here will be in CosmosDB as a sync. So they have given a complete example of how the data is actually getting transferred from one particular source to a destination, which is a CosmosDB here. Okay. So with that, I think we pretty much covered everything from a CosmosDB from an exam point of view. Remember a structure, the APIs, the consistency level, and then obviously the operations on top of that. Operations are handy. That means you are creating a model, correct? Then how the global distribution, that is physical partitioning, and the multi-region multi-master model. Similarly, the partitioning, how you actually partition your data within the region versus the multi-region, and scaling obviously depends upon the clusters and what kind of the scale capacity. That means RUs you require. RUs are nothing but the processing power, which is capability of CPU memory, and the networking IOs which you will be requiring to have that in place. And indexing is nothing but more on how you can search faster, parallel processing versus synchronous processing, tracking the change with the help of the chain feed processor, push model versus pull model, reading a specific feed and populating the respective content is what the change feed example we have seen. And obviously when you write the respective queries, then you should know how you have to actually write those queries. Select, you should have very well versed with writing those select statements and working with them. As an example we have shown. Security, I think right from networking, firewalls, and obviously setting a role-based access control is what we require here. Migrations is how do you use a different tool, and what are the prerequisites are required is covered in the migration. So that pretty much covers our CosmosDB. Now let's get started with the Azure storage. So I will just pause here before we start with an Azure storage. Just have a look at this table. So on Azure storage, first of all, just see what are the different kind of accounts you can create. General purpose, premium block, premium file, and then premium page blobs. All are used for different purposes. Like means if you see for a general purpose, it's more on a blob, queue, table, and the general purpose accounts which you see. And then if you see premium block, it is more on the blob storage only. Similarly, a file, again this is on the Azure files, and similarly the page blob. Page blob nothing but the disk, so page blobs are only for that. And you see the redundancy options, because in exam there will be obviously a question of what are the redundancy options you can have while you create one particular account for so and so general purpose versus the different accounts. You should be sure of what kind of the redundancy options are available for them, and if they are available, then there will be also some limit. That means the 50 GB limit or something of the limit is posed on some of the constraint if you do the a multi region replication. So those are things you have to take care of, which kind of account will support what kind of the redundancy option and what are the services available within that. So that is what is expected out of you from an Azure storage while you are integrating from a development point of view with the different storage solutions. Okay, so general purpose is mainly for everything on in and across the queue table and Azure files. However, if you look for the premium, I think they have obviously the SLA points, and obviously the redundancy options are very limited. That means LRS and ZRS is only supported. And if you see ZRS also, for some of them, I think there will be respective restrictions on the file size as well. Okay, so just read out through what are the redundancy options and what each particular service supports for that particular account. Okay, now this was a one. Then coming to the again the graphical representation of a service, a blob basically above us for the accounts. Okay, so this was redundancy account for accounts, but if I break down these in a respective services which are written here in second column, this is what the map will look like. Sorry. A blob storage, queue storage table files managed. So what I see is LRS, ZRS, pretty much blob queue table supports all of them from a redundancy, but files are restricted to only LRS, ZRS, similarly GRS and GZRS. Now wherever 1, 2 are written, there's a meaning towards that. As I was saying, while you do the multi-region or even within region for some of the files, I think the restriction is it should be less than 5 terabytes in size. Okay, so for 1 and 2, similarly premium files are supported. If you are going for premium, I think we have also seen here premium, they only supports LRS, ZRS, LRS, ZRS. They don't support any other redundancy options. So in exam, I think you will be asked only on these particular pointers. So remember, this will be very helpful while you attempt for that exam. Okay. Now till here, I think we covered what we have seen from the what are the accounts we can create and what are the redundancy option. But what about how do we manage the movement of the hot data to cold versus an archive? Is where the lifecycle management policy will come into picture. That means for a standard tier, especially if I'm having a standard tier, I can move the data from hot to cold, and at some point of time I can move to the archive. So this is what the standard tier supports. But while I'm in the premium tier does not support hot to cold and archive because it's a premium tier. You can only have a policy applied to that and delete the data after certain point of time, or maybe after particular weeks or months, whatever you have set the policies for. Remember, hot to cold, cold to archive is only available in standard tier, not in the premium tier. This will be again the question in exam, which you have to remember. And how this lifecycle management policy looks like is the example I have just pasted below that. There are rules, and these rules will have filters. That means if I have to filter on something, I have a filters only for blob, and if I want to have a specific path, I can have that path as well for that particular container. So that is why I'm mentioning here. Now I have the respective filters for blobs, and also have the container. Now within that container, what I have to do is the actions. So if this particular policy is enabled, okay, so actions after 90 days, okay, so delete days after creation greater than 90 is what here is written. Okay, so previous version delete after 90. And if I have a base blob which moving from hot to cold after 30 days, if there is no modification to that, 30. Similarly, days after modification greater than 90, I have to move them to the archive, is what is written here. And final delete, that means for compliance reasons, I think this is 2555 is what it is being written in the days, where this particular data will be deleted or the blobs will be deleted. So this is the lifecycle management policy you see through for a blob storage. So again, there will be an code given to you, and you have to select an appropriate drop down or maybe answer yes or no based on whatever the code you have understood. This will be also a part of your exam. Okay. So remember, there are two parts to it. One is filtering what exactly we want to actually apply the policy on, then apply the action on top of that. The action will be basically versions you want to retain, and then if you have retaining that button within that version itself, when the data will be moving from hot to cold versus cold to archive is what we have set here, and finally deleting that after the compliance, maybe for that particular interval. This is, I think, near to 7+ years. Okay, now this was for moving the data from hot to cold, and how do I or what are the time limits if I want to get the data back? So that is where what is written is a rehydration process. That means getting the data back from an archive. Okay, so if you go with the standard priority, you will minimum you have to wait for 15 hours to get the data back. But if you go with a high priority rehydration, then you will require less than an hour. But make sure whatever one particular file you will retrieve with that is, it should be less than 10 GB in size. So these are the limits which again will be asked in exam. But if it is more than 10 GB, what to do? I think it purely depends upon the data or the amount of the data. It should be available in a day or so, but I think it can take more depending upon the data or file size we have within those particular blobs. Okay. And now, similar to whatever you have seen in auditing and the change feed in CosmosDB, you also can have in your blobs. How to enable that within your account? I think you have a data protection as a tab. In that particular blade, I think you have to enable the change feed. And what are the things you need to keep in mind is basically while you create that, there is a separate container which will be created, because obviously we need some kind of the storage which will keep track of these state changes. Okay, so blob change field would provide us with that. Similarly, whatever the changes which you want to capture, create, update and delete for the blob will be available. And obviously there has to be the on which particular accounts this was available is what they have written clearly here, which you can enable. Obviously this will not be available for your hierarchical namespace, which is the Hadoop systems. So as of now is restricted to what these accounts which you have seen, which you are being used for your general purpose storage along with your premium block and the blob storage. Okay, so this is pretty much how you do for the storage account. Now how do you read them, right? So there should be process to read those, right? Again, the change feed, make sure, I think being a developer, I think we should be very well aware of the CLIs. How do we integrate those particular binaries with my application, or how do I read those? So first of all, you have to add a respective packages and get those code generated, or I would say leverage the existing templates of whatever the task list before I can. So this is programmatically I'm connecting to the blob service client, and then I'm connecting, listing the change events. Okay, this will give me whatever changes, whatever update or delete or something happened on those records for the. And finally, obviously I have to also provide what there's output, right, to console. Now this will also be, like as I said, being a developer, I think we have to make sure what libraries are available, what are the respective I would say resource provider packages you have to add before I can read, because this is nothing but the classes or the namespaces being populated based on how you interact with the Azure storage, and then you read those events then out of that. Okay, so these are the pretty much good examples. I think in exam you will get these kind of snippets, and you have to fill some of those boxes depending upon our understanding from these particular change feeds. Okay, so remember, this is how we will go through this particular examples. Now coming to the static web app. Now, static web app obviously is using the storage, but it is more than a storage. Uh, as we are using some static contain, we also want to make sure if there is any changing happening on repositories. Now repositories can be on GitHub, it can be on Azure DevOps. So we are creating actually the source control system where the code is actually being fed and being promoted to the production. So once the code is fed and promoted from our development environment, then that is available out of box in a web app. And to do some kind of work or actions, by default you have an Azure functions as a processing engine. That means some actions, but apart from this you can also have other backends like API managements and the different other services which you can integrate with these particular static web app, so that the actions are done by those services. Okay, you are actually doing the front end, or I would say even the content delivery and everything can be integrated with that, so that whatever the static content is being pushed through, that is being available across the globe through the content delivery network. So these are the I think some of the things which will be tested in exam. Similarly, how do you configure that right from scratch is given in this configuration example. Like while you are done created your first static web app, and what are the different things you have to do from a configuration aspect, right from creating a routing rule. Routing rules is nothing but if I am being hit on the so and so blade, or I would say a virtual path, how what will be provided to that particular user. It can be a file share content, it can be videos or streaming content. So those are the different routing rules you can have on top of that. Similarly, if I'm promoting my code from a development to integration to production, then I should have some branching strategy in place. Who can access everything is from a the example scenario they have given here. And if you see the application configurations as well, I think pretty much each and every topic they have explained, right from authentication, authorization, how this will look like, and what are the different properties we can embed in our code, and how these routes will look like. Okay, so these are basically the different, I would say, the configurations they have already given for a static website. We just have to follow this and actually create this particular automatically, right from the either you are using the Azure versus GitHub actions for creating this particular static website. And how do you build that and also push the code is also can be automated. And finally the app settings is what they have shown, how this will look like in the your JSON file. Okay, so basically all configurations, the database connection settings, and how do you connect to the another different services from integration aspects is what they have given step by step. So static web app, this is the configuration, and web app security is more towards how do you authenticate. Okay, so if you are using the Microsoft Azure AD, which is now Enter ID, then obviously the .auth login AAD is the sign-in route for that. But if you are using GitHub login, then auth, that is how you have to integrate this in our the JSON or configuration files. Okay, so this is how this particular integration, how you're setting sign in, sign out, and authentication providers. So there will be examples, short examples testing you on how the error pages should look like if you are not actually being authenticated, how the error code. So this is how the integration of this particular static website looks like. So in static website, I think mainly we shown what exactly the static website look like, what are the different configurations and security. Now coming again to the last part, similar to our Cosmos DB, is how you work on these operations on the Blob services. So let's look at one by one. Now, first of all, when I say metadata, there should be some structure to it. That means a header. Okay, so we want to understand how we interact or operation on the, first of all, we should be very sure of what the header means to us and how this look like. Once I'm sure of the header, I should be able to use using APIs. That means I will be using the get, put operation, even set operations on top of that. Get header, then this will be the URI of my a blob container. Okay, this is a URL. If I want to give a blob, then obviously again same, but then here I will be appending my blob and then giving the what kind of the metadata I want to get on top of that. So this is how you create your own URLs. And also in exam also you will be asked to create a URL based on whatever the container name and the blob name they will be giving to you. So put is more of a setting, kind of the putting the data or the metadata on that container versus even creation of that. Then finally getting is nothing the reading of the tag. There are examples they have given. Similarly, the standard HTTP headers supported are only these. Similarly, the standard HTTP supported on the blobs is all from a modified content length and type, but for container it is an e tag, and this is e tag is mainly used for you are actually tagging that content for a specific purpose. So remember, these are some of the things you have to remember while you have to do the operation on this metadata for blob services. So let me move on to the blob inventory and indexing. Now, as I am already been talking, what are the changes happening, or for auditing purpose, I have to really know what the inventory of what exactly the structure of the containers, blob, and what is being created. So I can get directly out of box in a different formats, and that is where it is allowing us to do for these particular accounts. And what are the inventory features or inventory reports I can get top of that is written here. So this is just a know-how of what exactly it will look like in whatever shapes and form, and how do I enable that. Now for each of these, I think they have like by enabling storage inventory reports, what exactly I have to do for that, they have already given you step-by-step instructions. Okay, you have to create an inventory rule and then go on to the respective blob and then enable. Okay, enable for what, and then which frequency, which format you want. That is how you can get the inventory of how your the blob and the storage account is actually structured and getting out of that. Okay, so these are the examples. I think they will test you on exam. Similarly on searching blob as well, how do I search within the blob or the, I would say, in respective accounts. Again, for that you have to integrate with the Azure search. They have given step-by-step instructions of how do you, within the account itself, how do you actually integrate with an Azure search and add that to your the storage, and how do you index them, JSON files versus CSV files is they have given, so that you should be able to actually extract details based on the different supported file formats. Now data protection, again we have been talking a lot about this. How do we protect? Now here data protection more of someone should not be able to delete that, or if it should be created once and then should not be accessed or should not be deleted for some years, or maybe for compliance reasons. That is where the data protection comes into picture. Now if you see, prevent a storage account from deleted or modified, prevent a blob from version. These are the different policies I would say, or putting some restrictions so that it should be either be stored for respective time period for compliance season, or someone should not delete it ad hoc, or maybe someone not knowing that particular should not be able to delete those respective files. So that is where I think different options are available to us, and based on whatever the data protection policies, you can leverage locks or some immutable policies. They have given basically what it does from a container, from an object perspective with the overwriting. So these are things we can actually get into the data protection policies, or I would say enable them based on the what we want to achieve out of this particular data protection exercise. Okay, now immutable, again this goes back to again regulatory and how this looks like. Write should be allowed, delete should be allowed. Again, what are the options available to you? Either you can go for time base, that means this is for compliance reason, has to be stored for some particular, or legal hold, that means until explicitly allowed or something, I should not be able to or have a delete those objects. Okay, so I'm just putting explicit lock versus time-based lock, and then regulatory compliance I'm trying to make sure of that I'm being taken care of. So ideally you will apply some data protection policies, immutable policies to take control of these operations on the Azure Blob storage. So, and this is what the different accounts or different resources which you have within Azure Blob storage. Now, this is mainly to give you a view of REST operations on your blobs. Now, if you see the REST operations, you basically put, get, even delete, okay, snapshots, everything. So you have to create a URL out of it. Now, these are the operations, but if you get to the each of operations, suppose if I want to just go onto the get blob, you will see that you are actually creating the URI and hitting the container and blob. Similarly, if you are actually, say, suppose I'm trying to see how to delete blob. So with that, what are the different options I can keep? Let's say, suppose if I want to keep the snapshot. So these are the different options I can leverage, right? So if you see delete operation, right? So it gives you the for snapshot, delete blob, snapshot of that particular date and time. Correct. So you can actually control. Similarly, if I want to not delete the data only snapshot only, I can include this delete snapshots only. So these are the different, I think, URL parameters you can add and you can try out. That huge list. I know this is a huge list, but I think for you to get hands-on, at least try out something, one on get, one on set, and another on delete, just to give you how these URIs are created and how you actually operate them on the storage account. Okay, so this is kind of a request response model which you have. You have to just create a, you have to use the respective URL along with the respective parameters. Okay, now last is the conditional operator. Why do I need that? Is to check for something whether this exists, and according to that I will take an action. So if something is modified, if there's a match or something, so that purely depends upon, that means apart from a normal search and indexing operation, I also have a conditional operators which can work on in a programmatic way to search for a respective content. If that matches, then I take an action on that, either delete them or take some operation on depending upon the requirement for that particular output. Okay, so they have given an examples on what are different conditional headers you can use on top of a blob. Okay, and depending upon the API version you are using, I think there are different headers available to you, along with the how you can evaluate them, whether you can evaluate them together or you have to run them without appending them with any other headers, is what they have given. So they have given example one, if match, if modified since. So these are the some of which they are using in either combination or they are using in an individual way. So examples, I think they have pretty much everything for what type of the conditional headers we are using for operational type, write, read and write, and accordingly use the respective headers for the conditional mapping. So that's all we have as a part of this session for developing solutions for Cosmos DB along with the blob storage.